Well, hello there, everybody. Today on Time with Steel Garage, we're going to rebuild a brand new engine, partially. So, if you guys remember the last time you tuned in, I'm still having trouble with this Ecoboost swap, and we thought it's mainly been fuel issues. In the last video, we thought we got it fixed, addressed a few issues in the low pressure fuel system, and then still didn't have fuel pressure at the level it needs to be at the rail on this engine. So I had a crazy idea in my head, and I'm like, man, maybe there's something wrong with the valve train. So sure enough, pulled the high pressure fuel pump and the cam is not turning. Now when I brought this brand new engine, it showed up with some shipping damage, and what happened was the motor fell off the forklift and landed on the top front portion of the valve cover, and it looked like it just had a broken valve cover, but what actually happened was it broke the cam phaser on the exhaust cam clear off the cam. We didn't know this. It must have been a hairline crack, and when we first tried to fire the engine, it snapped the phaser. Now, this is an interference engine, so we got really lucky. I did a leak down test, and all the valves are okay. The only thing that saved us was that the cam chain stayed on and tight enough that the intake cam stayed in time, and the exhaust cam snapped in such a way immediately that none of the valves got bent. Now, these are new cams sitting on top of the block. I haven't done anything quite yet. I disassembled the whole motor. I'm tired. I'm having a hard time getting moving this morning. But I realized there's not that many videos out there, if really any, that show how to do a cam swap on an Ecoboost. So I figured I'd throw this together for you guys. I can tell you, 2 bad engines in this car. It's a series of bad luck, man. I think this is going to fix it. I think we're going to have it running today. Hopefully, fingers crossed, that there was no damage. Now, the internal leak down test passed. I'll do a compression test after I rebuild the top end. But I'll tell you, as a business owner, I'm done with buying secondhand engines or new engines from not primary vendors. If this engine doesn't run this weekend, I'm buying a brand new crate from Ford Performance. Just the liability for me is just too much. Had this been a customer's car, I'm now 2 engines deep, and this particular long block brand new was about $3,000, and because of my mechanical ability, I should be able to fix it. But you know, if this was a brand new crate engine from Ford, I'd pick up the phone, I'd call customer support, I'd say, hey, the motor's bad, they'd send me a new one. So I think I've made the decision as a business owner that any of these swaps I do in the future, they're going to be new crate engines. Because if you think about it, like, yeah, you buy a used engine, look at all the time I have in this car wasted between these 2 engines. So if you add up all my time, I've easily exceeded the value of a new crate engine. So anyways, enough blabbling. I spent about 5 minutes extremely pissed off, and then I tore the motor apart. Now, the good news is, to get to this stage here, if you know what you're doing, it takes about an hour. The first thing you need to do is get yourself a nice clean surface that you can organize parts and lay parts out on. Now, these Ecoboost engines are actually pretty cool in the sense that Ford sells a timing kit, or any of the, you can get them on Amazon for like 40 bucks. But before you start disassembling this motor, you need to take the crank timing tool from vendor of choice, pull the plug out of the side of the block where I'm showing you right here, thread this in, and you basically turn the crank clockwise until the counterweight of the crank actually hits this bolt. And you can see right there where my finger's pointing. Let me get some light here. That is physically the side of the crank hitting that bolt. So the motor is at top dead center, okay? Then you pretty much, the rest of it's pretty much common sense. Spark plugs, coils, valve cover, high pressure fuel pump housing, vacuum pump housing, water pump pulley, belts, all your front accessory pulleys, your crank, harmonic balancer, timing cover, everything pops off. So that's where we're at here. The thing with these cranks on these motors, one of the weaknesses of an Ecoboost engine in my opinion, is the crank is not keyed. The harmonic balancer is a pressure fit, so that's why it's very important to have these alignment tools. Now most of the guys that are building high horsepower engines, they're doing keyed cranks. But anyhow, the intake cam I was able to save. It's in the box over there. Who knows what I'm going to do with it. The exhaust cam, you can see here, is just destroyed. Now the phaser is okay. So really, we might get away with just a simple cam swap here. So I went ahead and ordered a Ford Performance set of cams for a 2.3 Mustang. You can't really beat this. I mean, it's 200 bucks for a set of high performance cams. I think it's just slightly more intake and duration and lift. Man, I need to have another coffee before I talk to you guys in the morning. But so I went ahead and got 2 brand new cams, and they're sitting in their home. I literally got the box, lubed them up, dropped them on the top there, and that's where we're at. So now we're gonna start putting the motor back together. And like I said, hadn't really seen any good videos on this, so I figured I'd go ahead and do one, and you guys can follow along or don't, but I sure hope you do. Okay, let me get my camera set up so you guys can see what I am doing. Okay, so the first thing we're going to do is I need to rotate the crank so that I can get the pistons all down from the top of the block. I don't want any of the pistons level with the head at full, because I want to be able to adjust these cams without bending a valve. So first thing we're going to do is we're going to thread the crank bolt in. And then we know it's at top dead center because I just showed you that. Now I'm going to get my rubber gloves here. The big thing with engine builds is cleanliness and stuff and things. So I think this motor's okay. I think we're gonna save it, so I'm gonna put it together like I care about it, because I do. And hopefully this afternoon I'll be on the phone with Mark and we'll be having a running engine. So number 1 piston is at top dead center. So this piston is the top of the stroke right now. I'm gonna take this crank bolt, snug it, there we go, and I'm going to mark 12 o'clock so that I can visibly see. Okay, now I'm going to take the timing tool out of the side of the block, and I'm going to rotate this thing 270 degrees. And now what that's going to do is bring every piston to where the top of the piston is just below the deck on the block. And that means it's safe to adjust the cams in place without damaging anything. Okay. I'm going to put my timing tool back in, because when we're done with the adjustments, we're going to rotate the motor all the way back around. Now what I've effectively done is, I want to cross thread my block here. Hold on a second. Woke up yet this morning. Okay, so what I've done is basically now all the pistons are slightly below the top of the block, right? And the number 1 piston is on its way back up. So now I can adjust my cams so that the top of the valve train is at top dead center with the number 1 piston. And then once I have them locked in and set, when I rotate that extra 90 degrees, the valves are going to be in a happy place to where they're not going to get injured. You see inverted fly right by, leather gloves, and stuff like that. So, all right, so the next thing we're going to do is physically locate the cams in the motor. Now, I'm going to show you on this bad cam here, the back of the cams are indexed. And if you notice, it's not a center cut, right? Because if you look at it from the top, that cut isn't centered, it's offset. That's a pretty trick from Ford, because what that means is you can't physically have the cams 180 out because your little tool right here has to go on the back of the block and slide into the cams to lock them level at top dead center. Well, the way they have the cams cut is that cut will be below the deck of the block if they're 180 out. So if your tool is not fitting, it's because your cams are 180 out. Now when you lay them in, I laid them in here to get them comfortable. The exhaust cam is pretty close. You can see the cut back here is almost level. The intake cam where it's happy is not quite there. So now I'm going to put all the caps on and I'm going to torque them down per the manual. If you don't have a manual and you're working on a motor, they're all pretty much the same. You want to start in the center, work your way out. Just a couple of turns per cap, and you just keep going until the thing's snugged. 2-stage torque on this per the Ford manual. The rear caps use anaerobic sealant on the block, and that's really the only thing special with that. Once I get the caps torqued down, I'm going to use these hex wrench casting marks on the cams to physically turn them where I want them to be. Then we're going to put the timing plate in the back, and the cams will be set. And then we'll just rotate this crank up to 2 until that counterbalance weight hits the timing mark in there, which should be 90 degrees, and then I'll face straight up and down. Once that happens, I'll pull this bolt back out. Then we can start putting our cam phasers on, our timing chain, harmonic balancer, all that kind of stuff. So let me get some of that done and I'll be back. All right. I'm gonna wake up and be entertaining, I promise. So when you're putting these caps in, the big thing to remember when you're taking all this stuff apart is that the bolts, the caps, everything, you want to put it back in its same spot. Now we did do new cams and there hasn't been much wear, but these valves are factory set and clearances should be good still. We just want to make sure we put the caps back in the same spot. Now this red stuff is assembly lube. Ford's manual calls for just using regular old 5W30 engine oil. So do what you want. I do things my way. So I'm just going to gradually put these caps on, make sure the journals are lubed, make sure the caps are lubed, and have all the parts where they need to go. Then I'll worry about torquing things down, anaerobic sealant. I'm saving the rear caps for last because I got to get the sealant on those. I'll have my torque wrench set up and all that stuff ready to go before I put those caps on. If you're new to wrenching, anaerobic sealant's meant for when there's clearances are like less than 1/1000th, and it's metal on metal. And your regular RTV room temperature valve, something vulcanizing, blah blah blah, I don't remember. Sealant is meant for when you have a larger gap, when you're trying to replace a gasket, something like that. When you have machine surfaces, you want to use anaerobic sealant, and it really doesn't take that much. You don't want to goop the stuff on, but This stuff right here it's not the greatest build lube. I like stuff that's stickier than this. This is Permatex Ultra Slick lube. I've got some Lucas stuff. This stuff is tackier than engine oil, but it still runs pretty easily. I like engine lube that it kind of sticks where you put it. But this thing ain't going to be sitting long enough for that to be a problem, so we're not worried about it. If you're worried, you better put a ring on it and some lube. Alrighty then. I don't know why I got the old Pet Detective stuff on the brain lately. I haven't seen that movie since I was a kid. I don't even know, is Jim Carrey even funny anymore? Or is he just an activist like every other actor? Alright, so you can see on these rear caps here, this is the exhaust rear cap. You can see where there's some leftover sealant. That's the anaerobic sealant I was telling you about. Look at how thin it is. I mean, you can barely see, you can easily see the color of the metal through that. So basically you're going to seal, well, I'll just show you. Messiest, worst sealant job ever, but you get the idea. Oh, what's going on? I said, hey. Man, whatever happened to that band? You remember that? Four Non-Blondes? Alright, so there you have it. Anaerobic sealant, anaerobic sealant. The rest of these are lubed. These are just started. Now I'm going to get in the manual and I'm going to torque center out. The Ford manual, which is open source nowadays, it labels it out super simple for you. 1, 2, 3, 4, 5, 6, the sequence that you got to go on the bolts. And the torques for the bolts are, oh, let me look. So you tighten them 2 stages. Stage 1 is 62 pounds, inch-pounds, 7 Newton meters. Stage 2 is 142 inch-pounds, 16 Newton meters. Now when you're bringing these down, you literally just want to do a couple of turns, and you go through the whole cam that way, because these cams, they're not designed to take load on just one bearing. Because you'll have a valve that puts a little pressure on here, and if you just torque that down, you can actually snap the cam while you're installing it. So patience is the name of the game here. Okay. Alright, I got. Now I'm going to get the bolt down to where it touches the cap. And I'm going to do that on all of them. And once you see that cap move even the slightest stop, like I said, without even looking at the manual, the easy answer is work yourself centered out. Okay. I need to drink like 3 more cups of coffee. Now, if you're looking at my intake cam and you're wondering why it looks a little funny on the back, I'm not running a vacuum pump on this motor. So I did not install the additional extender that goes on the back of the cam to run the vacuum pump. I'm running a Mountain vacuum delete, so I'm not putting that piece on the cam. Now I'm going to get my torque wrench and start doing the thing. So we want 62 inch-pounds. Ford says 2 turns at a time. So I'm just going to take that mentality. I'm just going to do flats. I'm going to be extra conservative. You want to make sure that this cam goes down evenly, or you just wasted a couple $100. 1, 2, 1, 2, 1, 2. Here we go. Remember with a torque wrench nice and slow is the name of the game. You don't want it to click and then go 90 degrees past unless the instructions say torque, then go 90. But I see a lot of people double click. You really don't need to do that. The torque wrench clicks, it's torqued. If you double click, you're actually imparting extra torque, and I'm guilty of doing it myself. It's just an old habit. I sound like that teacher from Ferris Bueller's Day Off. Bueller, Bueller. Anyhow, clicky. You guys probably hate it when I sing. We're going to go to stage 2 on the torque. Let me double check the torque, and that is 142 inch-pounds. So you can see we're stepping it up. A lot of times if I'm working on something on a car that is a torque yield bolt and I don't know the torque and I can't find the reference, or I know the final torque and it doesn't get a step torque, I like to do, like say a flywheel bolt's torqued to, 145 foot-pounds. I'll step it up in thirds. People don't use torque wrenches and they do good and tight and all that kind of stuff, but when it comes to cams, man, your oil tolerance is so minute. I want to say, I don't remember what the manual says. I want to say it's 0.10 to 0.12 on the lifter clearance, because it affects the oiling of the cam, and if your cam's not oiling right, then your motor's not lubricating right, and you're going to have metal on metal. Ultimately, what kills engines? Oiling. We can't time our cams with these rear caps on. So our cams are torqued now. I'm going to take the rear caps off. The front cap is just sitting on there. And we're going to put our timing plate in. How the number 1 should look. And what we're trying to do is there's a straight line on the back of each cam that we're trying to get level. We'll know if we got it right if the plate goes in. I'll probably have to finagle it a little bit, but if the plate doesn't go in, then I'm 180 out and I'm an idiot and I need to adjust. I mean, I'm still an idiot, but... Okay, so you can see this cam is still cocked a little bit, so I'm going to rotate it with my plate in until it's happy. Really tight. So there you go. I'm going to show you what this guys show you guys what this looks like. So now you can see what I'm talking about. Now obviously your high pressure fuel pump's driven by this 4-lobe cam at the end here, and your housing bolts here, so that's why I had to take that rear cap off. Your vacuum pump bolts here, I'm not running it, so it doesn't do anything. That cap's off right now so that I can put the tool there. So now the cams are physically timed at top dead center. So what we're going to do now is bring our crank back to match the head. Now if I did this right, we're not going to hear anything surprising, metal on metal, or feel anything funny. If I did this thing wrong, then I'm about to bend a valve. So wish me luck. Nope. She went nice and smooth, so we did it right. And there you can see my timing mark back at the 12 o'clock, which I loosened the bolt a little bit. That's why it shifted. But more importantly, the bolt doesn't matter. What matters is that the crank itself is physically up against that stop. Okay, so we're good there. Alright, I leave the timing tool in the back of the block. Now it wants me to torque down the front cap, which holds the variable valve oil sensors. The manual has you take those sensors out. I left them in. Same torque as the rest of the caps. 62 and what is it, 140, 142. All right, we are torqued there. Now I believe the next step is to finger tighten the cam phasers on. Before we put the phasers on, we want the front of the cams where the phasers rest on and spin inside of to be lubed. Make sure you put these on the same side you took them off. Should slide right on easily. If it doesn't, there's a problem. Should also spin easily. Check your teeth. In this case, I got lucky. None of it. This phaser's fine. It didn't get damaged. Manual just calls for finger tight so that you can move them. Okay, I'm gonna put the intake side on, nice and lubed up. Phaser's on. Spins freely. Teeth are all fine. Thing's brand new. Still has the laser etch marks on it from the factory. Alright, I'm going to leave them quasi loose there so I can manipulate them with the timing chain. Well, wouldn't you know it, the manual's right. You do have to take the timing chain guides out and the dampener. I just put this one back in, but you're not going to get this chain out without following the manual. Go surprise there. Okay, well, I'm going to assemble this all back together. Alright, so it took me a couple of minutes to figure this out because I haven't changed the timing chain on this motor yet. So the way you got to do this is I took this guide completely off. I took this one completely off. Put the chain on, line everything up, put this guide back on, put this guide back on. Slightly out of sequence from the manual, but works better. Now the tricky part is the tensioner. The manual actually calls for this, and I tried to do it without doing it this way, but believe me, you have to do it this way. You have to use a vise, and there's a little C-clip right here that you have to gently walk along the shaft as you compress it. Hopefully that's compressed enough. I think it is. It seems to be where it's happy. Now I'm going to move it over without the camera because this is tricky. You put the pick inside there, it keeps the shaft from popping out, then you move the tensioner over and lock the bolts down. Alright guys, by far the hardest part of the whole cam install, which it really isn't that hard. I just wanted to show you guys this because this is the trickiest part. So again, when you put the timing chains on, these are finger loose. I could rotate these. I put the chain on, took both followers off and the tensioner, got the chain around the crank gear, put the top of the dampener side tensioner on, bolted the black tensioner rail back in, and then the manual, you take this over to a vise, you gently compress the piston while you move that tiny little C-clip with your fingers, you move it up the shaft, and then you lock it in place with a pick. I found the 90-degree pick worked the best, and now when I pop this out, it's going to be under tension. There you go. Boom. Alright, your torque's here and here, 89 inch-pounds, and your dampener torque's also 89 inch-pounds. Alright, I believe I misspoke on that last step there. Obviously I can't put the crank harmonic balancer back on until the timing cover's on. The manual calls for a 23mm wrench and 53 foot-pounds on the phasers. So you're going to hold the cam, and it is a 15mm socket, not a 14. You don't want the timing plate in the back to be holding the cam. You want your arm to be doing it. Oh man, I was worried about that. That was tight, fellers. It's kind of scary torquing on a cam like that. You 3.5 fellas out there know how important these cam phasers are. Oh, there she is. 53 foot-pounds, that's kind of hard to do with one arm supporting the cam and the other one torquing the spec. But now, remember in the beginning of the video I told you guys, when you're laying parts out, bolts matter, dampeners matter, all that stuff matters. So exhaust cam phaser sticks out further than the intake phaser. The intake phaser bolt sticks out further than the exhaust phaser bolt. So when you take things off your old engine, immediately set them in an organized sequence so you don't mix them up. And you can use paint markers in case you knock the table over. Take pictures of everything. It helps you in the long run. So that is pretty much that. This motor is timed and torqued. Double check that your crank hasn't moved. Everything's tight now. So for all intents and purposes, the hard part of this whole job is done. Now we have to RTV the cam or the timing cover. The timing cover's got like a bazillion bolts that go on here. There is a certain sequence. There's RTV that goes around these 3 holes here. All right, so I got my gasket maker on, which I'll tell you right now, Ford uses this stuff called TA31, and it's phenomenal. Mine was too old to use. I ordered some, it didn't get here in time. Nobody in town has it, and I wasn't gonna wait for it. So I got some good old-fashioned Wright stuff here. Now the goal is to be as pretty as possible. You do have to put sealant around where all the bolts go in on the inside of the cover, as long as a bead on the bottom. And the manual also calls to put a straight line where the head meets the block on both sides. Now, I'm gonna go ahead and put this on. Now, there's a gazillion bolts and there's a couple special ones. So I'll go ahead and what I'm gonna do is grab the one very special. There's a bolt with the star head on it. That's the very bottom center bolt above the crank. So now we're gonna feed this on. So this bolt right here goes right above the crank seal. Three large bolts that have a foot-pound torque, those go in these larger holes right here. Now the cool thing about Ford is all the bolts are sized so that you can't put a bolt in the wrong spot, except for maybe the length of the bolt. So I'm just gonna get these all started. Since I'm using Wright stuff, I like to let that stuff flash for a little bit anyhow. Probably like 5 minutes. TA31 with the Ford manual, you have 10 minutes till that stuff is, according to Ford, where they want you to rip it back off. And I can attest to that. That stuff is really awesome, but man, you are on the clock. It turns to rubber really fast. So I'm going to use my phone. This is where taking pictures helps. I'm going to use my phone. All right, I got all the gazillion bolts in. So your 3 studs go here, here, and here. Here, here, and here, okay? You've got a star head bolt right there, and then all the rest of the bolts are the same all the way around, okay? Except for these 3 right here. Now all the bolts that are small diameter on the cover are 89 inch-pounds. These 3 large bolts are 35 foot-pounds. Now there is a torque sequence that's ridiculous, but the general idea is just, you know, 1, 2, 3, 4, 5, 6, 7, 8. You just work your way center out, up and down. Here is the actual torque sequence. I don't know if you guys can see that, but I'm gonna get busy torquing and then I'll be back. Okay, we're cooking with grease now. So the next step here is to actually put the harmonic balancer on, which this is a very critical step with this motor because it's not keyed. I say again, it's not keyed, which means if you bolt it on wrong, then your motor is going to be out of time. And since the actual internals are timed together, it's not going to hurt anything. However, since your crank trigger is very sensitive on this engine, if the harmonic balancer is not installed correctly, it will never start. So I got my gloves on here. I'm gonna get some assembly lube, pressure fit torque. At the bottom of this crank wheel is a hole. Okay, that hole corresponds to this threaded boss on the timing cover here. So when you get this on, what I'm going to do is put a bolt in here. I believe it's M6, and that's going to hold this where I want it. Now you will rip that bolt out of that timing cover real easily, but when you go to set your crank sensor on these Ecoboost engines, the procedure doesn't have you put these timing tools in the side of the block, but it does have you line this crank wheel up with this hole. So it's important, I guess is what I'm trying to say, people. Seal, do you? Look at that. Slide in like butter. Like butter. Butter. Now, if you've got a couple of these motors laying around like I do, I keep a spare M6 bolt for the timing tool with my timing tool set. You can actually rob one off the bottom of your oil pan. One of these bottom bolts right here on the timing cover will work. Pro tip. Now you can see here I'm threading in this bolt because I want to make sure that when I go to set the time, if I ever have to replace a crank sensor, that I don't have to go through the trouble of taking my motor mount off and putting the timing tool sets in. I want this thing to be where it's supposed to be. You know what I'm saying? You know what I'm saying? This bolt goes on dry. You don't lube it up or anything. Now, the manual wants you to use a big old rubber strap to torque this. I don't have one of them, so I'm just gonna wing it. 74 foot-pounds, 90 degrees. 21 millimeter bolt. Oh yeah, it wants me to go an additional 90 degrees, so I'm going to take my white marker pen here. I'm going to make a new mark, a freshie, and then I'm going to make a mark on the side of the crank wheel where I want it to be. See what I'm talking about there, Snake? So now I'm going to tighten this bolt until that white line meets up with that white mark. Snake. I'm here to tell you that that bolt is on there. That is, I'd use a breaker bar to go 90 degrees. But I mean, remember, this isn't keyed, it's all torque, so it's very important. Now is a good time. Don't forget to take this bolt out, because if you turn the motor with that bolt in, it'll shear it right off. Ask me how I know. Also, good time to put your crank sensor in. I'll show you how to do that here in a few minutes. And we're pretty much at the point of cleaning up the front accessory drive. You got to put an RTV, straight line RTV where the timing cover meets the block and where the rear main caps meet the head. And then it's just simple after that. Fuel pump housing goes on, vacuum pump if you're running one of those, or block off plate, valve cover, spark plugs, coils, intake, anything else that you may have disconnected. I've disconnected more than I needed to because I had other stuff to do, but we'll keep you going here. All right, here we go. So the next step here is our crank sensor. Now it's very important on this engine. There's so much garbage on the internet about this, it's almost hard to comb through it all, and a lot of it is not right or doesn't make sense. So I know that I'm at top dead center because my crank is up against my timing bolt. I've got my M6 bolt in the crank. I've loosely threaded on my crank sensor. This little guy comes in, I mean, Ford sells them, Amazon, everybody sells them. You literally just go over the top of the sensor like this, see? Like that, and you push it, it'll line up with only one of those timing marks. You see that? Physically goes around it. Then all you got to do is tighten the bolts down. The torque is 62 inch-pounds. So you leave your little sensor cage around it, push it up against the crank wheel, and torque it down. That's it. All right, so that's it. That's the crank sensor. That's installed. Now's a good time. Take your M6 bolt out or you're going to forget. I'm telling you. Take your cam tool out. So we're timed. Our motor is timed. And just to make sure nothing crazy happened, I'll go ahead and take, I'm going to take the cam plate out. Okay, so cam sensor, or the cam alignment tool is out of the block. So the cams will now spin freely. Last step here is to take the crank alignment tool out of the block. You can see that's all it is. And then here's what that cam plate looks like. So your timing kit is literally the cam plate, the crank plate, and the special tool to put the crank sensor on, which you do need that tool. You can't visually eye up the crank sensor. It won't work, I'm here to tell you. And then you take your block off plug here. It's 177 inch-pounds. You feed that back into the block. And once I torque that down, now we should be able to free spin this motor now. All right, we got our rear caps back installed. I took them off, or cleaned the anaerobic sealant off of them, and put it on better. I forgot to mention on the exhaust cap, on this side, this rear cap is actually serving a purpose, right? And it is a bearing surface for the cam, and there's oiling passageways in the cap. You have to make sure that you don't block those oiling passageways with anaerobic sealant. This side, since I'm not running, on the intake side, I'm not running a vacuum pump, all this cap's really doing is providing a mounting point for the vacuum pump delete plate for mounting. So 62 inch-pounds on stage 1 and 142 inch-pounds on stage 2. These motors take an incredibly large amount of fuel pressure, 40 to 60 bar to crank, which is like 600 psi, and then I think running fuel is 80 bar, which I believe is about 1100 psi if I remember correctly. So a lot of fuel pressure in these engines. Just in case you're wondering, 62 inch-pounds is barely more than snug. All right. Now, everything is torqued, but just because I was talking in this video, and I don't trust myself sometimes when I'm talking, I'm going to go back through and torque the cams completely at 142, and I'm going to mark each one with a paint marker to verify that it's done, right? And I recommend doing this regardless of how good of a wrench you are. People make mistakes. The last thing you want on a motor that's running this kind of pressure is a cam that is not torqued properly. center of the bolts. Or just marking the bolt in a way that's obvious. Alright, so now I've got visual indicators that everything's torqued for my own good. And let's see here. And that's this little guy, this housing here, and you can see the cam rotates right inside of there. The Gen 2 2 liters and the all of the 2.3s Focus RS Mustang run this style of pump housing. After all the things I've been through with this car so far, I want to see this cam turn. Now this uses a rubber gasket that's built into the housing itself. Same theory applies as everything else that I've shown you to do. You know, you want to evenly apply torque across a O-ring style gasket. Alright, are you still there? We're almost done. Okay, so 133 inch-pounds on the high pressure fuel pump housing, 133 inch-pounds plus an additional 60 degrees post torque. Gen 2 2.0s and all 2.3s Focus RS Mustang, they use a roller style tappet. It's keyed so you can't put it in wrong. Lube this guy up, put some lube in there on that brand new cam, drop her in, and we're ready to turn this over by hand and find out if I just wasted my time completely. Okay, I poured some lube down in there. You guys still with me? Bueller. Bueller. Alright, my roller tappet is installed, and now for the moment that we've all been waiting for. Well, some of us. I'm going to turn this thing over, see if something happens. Oh yes, yes sir. Everything is turning. Everything is awesome. Let's look at that pressure piston back there. Is it going up and down? Oh, I believe it is, good sir. I'm going through several rotations to make sure we hit top dead center on each piston. Everything sounds happy to me. Well, that, my friends, is a cam swap. Only thing left to do that I'll show you, because I'm not going to bore you with all the other little things that got to go back on. The only other tricky thing, which isn't even tricky, is you got to put a little RTV on the block for the valve cover. Anytime you're going to put RTV down, make sure that the area is clean. Make sure the RTV's shaved or as close as you can get it to being shaved. And we're going to put a little RTV on there for the valve cover. Going to put a little RTV. The valve cover touches the timing cover on each side. And then you want some on the rear cam caps up against the corner of the cam cap where the valve cover is going to come down, just to keep anything from leaking out of there, that if that anaerobic sealant doesn't stop it. That's it, my friends. Now we're going to put the valve cover on, because you know. Okay, there's nothing crazy in there. I didn't leave a socket. Everything's torqued. Here we go. Boom. Cam swap complete, my friends. We are back to the state of the motor before I figured out that the cam was snapped. Before we try to start it, we're going to do a compression test, which would really show if I screwed this up. And then it should pass, and when it does, we'll try to crank it. And I should be starting to try that process this afternoon. So, might not be in this video, but it's coming, my friends. So, hey, thank you for dealing with tired, monochromatic Bueller Jimmy this morning. But I hope you got something out of it. Just because I couldn't find any decent videos on doing a cam swap on these motors, and I didn't need the video, but it sure is nice to just watch what you're going to do before you do it, you know what I mean? So hopefully this helps somebody out. This will work on a 2-liter Focus ST, this will work on a Ford Taurus, an Escape, a Mustang, a Fusion. If you're running a 2-liter or a 2.3 Ecoboost, some of your little parts might be different, but the overall concept is the exact same. The 2-liter and the 2.3-liter were all born from the Mazda Duratec block, and they have the same basic architecture. So anyway, thank you. We'll see you next time. All right, folks. Well, 46 hours after I discovered the motor was bad, I have rebuilt it, swapped cams, and it's ready for crank. Wish me luck.